involving in the construction can interact with Mr. Karthik Priyan for the clarification at the end. So on this occasion, I welcome our Honorary Secretary, Dr. Sadish Kumar, and immediate past chairman, Dr. Tangara sir, and immediate Honorary Secretary, Dr. Dhavamani madam, and senior members, Engineer Rashmanan, Engineer Muthuswamy sir, and other members participated here. So very few attending regularly, and I request please pass this information that every Wednesday we are 7 p.m. we are organizing the online webinar. So ask your friends to join. So once again, I welcome you all the members, senior members and student members presented here for this 123rd webinar series of the engineering talk. So I request Engineer Aramunga sir to introduce our today's chief guest and carry on. Thank you all. Thank you.
Thank you, sir. Now, I am privileged to introduce the chief guest of today, Engineer V. Karthik Priyan, Geotechnical Engineer, Civil Testing and Consultancy, Tyagaraja Polytechnic College, Salem. Engineer V. Karthik Priyan is a highly knowledgeable geotechnical engineer, offering comprehensive expertise in all facets of soil investigation, from meticulous planning and execution of bore drilling, test pits, and precise sampling of soil, rock, and groundwater to rigorous laboratory testing for determining crucial parameters such as soil strength, compaction, permeability, and moisture content. His proficiency extends to in-depth data analysis and reporting, enabling accurate assessment of soil bearing capacity, stability, and potential geotechnical challenges like liquefaction and settlement, culminating in the preparation of insightful geotechnical reports with tailored recommendation for foundation design. Furthermore, he provides expert foundation advice through monitoring and diligent inspection services. With these words of introduction, I would like to invite Engineer V. Karthik Priyan to present on the topic quality control in construction. Please, sir, forward to Engineer Karthik Priyan.
Hello, sir. Thanks for the introduction. Are you able to see my screen? Sir, is the screen visible and am I audible?
Yes, sir, visible and audible.
Okay, sir. Good evening to all. Good evening to Engineer Loganathan, Chairman IEI Salem Local Chapter, and Dr. R. Sadish Kumar, Honorary Secretary IEI Salem Local Chapter. Good evening, sir. And thank you for my introduction, Mr. Arumugam, sir. And good evening to everyone present in this meeting. Today, we are going to see the quality control in construction. Why this topic is needed? That is the first question while presenting this presentation and while preparing this presentation to this meeting. During my preparation, I come to know there are major safety factors and various factors involving in the quality. Everything in the construction is not at all a cost minder, and everything is not at all a quality minder in nowadays. But in my point of view, while we are going for a good quality, the cost also coming to reduce, or it will be optimized. The importance of the quality control is what we are seeing. First is safety and risk management. While talking about the safety, while we are going for a quality construction, by checking everything, the safety is dominant in the construction side. While doing everything in the quality and we are using the quality material and the site safety, the risk will be eliminated. The next thing is cost efficiency. While going with the quality, we are minimize the rework. and any other maintenance issue. It will decrease our cost in the meantime. And one of the main things, client satisfaction. If our one building is completed and a client will utilize the building, if he won't do any maintenance for a long period of time, he will give more and more projects to the same engineer or the firm who do the construction very quality manner. The next point is durability and standard. Durability is nothing but we do the quality building or quality, we are using the quality material. The durability period will be more when compared to other materials. And we should maintain some standards to in the construction phase as, as we have standards for all type of constructions and the construction materials and the efficiency that while maintaining the all the quality, it streamlines the construction process, and by maintaining the quality, the construction will be completed in the on time. Then performance and functionality. These are the main factors comes to my mind while I am preparing for the quality in the construction. We'll look into it. What is the in the end of the presentation, you'll know how I interpret this point with this meeting. And first one is quality management. What are we need to do before construction and during construction and after construction? Before construction, the first thing after we get the plot or we allotted, we are going to do the construction. The first thing we do is the soil investigation before the construction or even before the leveling of the site. And next to the quality soil investigation, we will go for the construction material quality check. The main construction materials I list out here. What are the materials we are using the most of the project? Cement, steel, brick or blocks, and coarse aggregate. Mostly we can stand or piece and any kind of fine aggregate and water. And next thing, after we are receiving the architectural drawings or we are going without any architectural drawings, we should follow some structural design to ensure our quality. And proper MEP drawings. Why I am including this MEP in the before construction itself means because once we plan everything in the meantime, before construction, we will reduce the cost in the during the construction or after construction. What are the requirements we need that should be we are listing out, and we should properly design that MEP and structural details and quality checks. Then we will go for it. During construction, to check on the quality, we should check the concrete quality and the concrete test, compression test, and we should periodically check whether the construction is executed as per the structural drawing. Because we will get the structural drawing, but we won't do the as per the structural drawings. We will do as it is meant that won't give proper conclusion in our quality. So we should periodically check the execution. During the execution, is the execution is as per the construction drawings or structural drawings. And after construction, if any leakage or any problem comes, we should go for NDT test. First, in the quality assessment, we will see how the soil investigation is done, why it is needed. That soil investigation, most of us know because we are come from a civil background. The soil investigation gives the bearing capacity of the soil strata or rock strata which is presented in our site where we are going to execute the building. The bearing capacity of the soil or rock is going to define what is the type of the footing, how is the depth is going to come, and how much settlement is going to happen. Because during that site investigation, we come to know raft or isolated footing or pile footing, if foundation is required or not, based upon our superstructure under the superstructure load. I quoted one quote here. Virtually every structure is supported on soil. Those which are not either fly, float, or fall over by Richard Handy. By seeing this code, you know how important the soil or the substructure in our in our construction field, and especially in the areas where we are going to construct or otherwise it will be flowed or fall over. First, what we are doing in the soil, in most of the places we are going with the standard penetration test, which gives us the SPTN value. That SPTN value is nothing but that growth required to penetrate 300 mm of piston into the founding strata. What we see in this picture, this is the typical standard penetration test, SPT test setup. This test is conducted in some Salem. By doing the setup, we have a hammer and a piston. That piston should be penetrated into the founding strata by using the hammer blows. I give the relative density and the penetration value in this table, which shows how the soil strata will be very loose, medium, dense, or very dense. For very loose, it will be less than 4 blows. Loose type of soil, it will be 5 to 10 blows. Medium type of soil, it is 11 to 13 blows. Dense with 31 to 50 blows. Very dense with greater than 50 blows. It is always recommended to go for dense and very dense founding strata to reduce our foundation.
Sir,
Yes, sir.
sir, how can I identify the residential building used for testing for soil? Which land area is the most constructionable residential building? Like
Sir, at the end,
first
sir,
we'll
1
take a
minute. At the end, you can interact. Let him finish the lecture, sir. At the end, you can
okay,
ask,
sir.
clarify. Continue.
Okay, sir.
This table is regarding only to the soil. The next one, if we are encountering the hard rock or rock strata while doing the SPT or soil investigation, what is how we treated the soil? Because in the construction field, what is happening now? Once we see some type of rock strata means of rock strata, we will treat it as rock. We will plan to do anything on the land, but that is not the correct procedure, because the core recovery should be at least 50% to consider it as a rock. Below 30% core recovery means that should be treated as a soil. But in regular fields, during the SPT, even though they going to do the standard penetration test, once they get this N value as greater than 50, they consider that layer as a rock strata. Then they will do whatever they want, they will do. But that procedure is wrong. The rock core recovery should be greater than 35% to treat it that rock as a rock. That is why I'm specially mentioned this rock coring and that core recovery. Yeah. What this is the important procedure before construction we should follow. At least we should do one SPT test in the site location to know what the founding strata. After we get the soil from the field investigation, we should do the laboratory test, which is fine, which is use the physical properties of our what we found in the strata, the soil. By comparing those two, this core recovery or this penetration value and the physical properties of the soil or the rock strata, we should come to know what is the bearing capacity of our foundation strata. And going into the material testing, I like to share one case study we come across during my job. This case study building, there is a structural failure in one RCC frame structure. We conducted NDT test, and collected some samples to know what kind of failure is that and how should we rectify that, why that failure is found. We conducted a non-destructive testing in that that building. Testers are rebound hammer test and ultrasonic pulse velocity test. This is the rebound hammer and this is ultrasonic pulse velocity setup. This is that building. In that building, within 10 years, the life of span of the building, life of the building is less than 10 years, but the entire slab is corroded and fall off. The client comes to us to know what causes failure and how should we rectify that. This is some failures happening in that slab. The rod is corroded and the plastic is fall off, and there are so much cracks in the column. You should see how worsen the building is within less than a lifespan of 10 years. The test results show the rebound hammer is conducted on slab which use the average compression strength as 22 kilonewton and 20 kilonewton. Which but what they are used in that site was M25 grade of concrete that used the compression strength as 25 Newton per mm square. The concrete quality itself is reduces. Then in ultra pulse velocity test, we kind of know how the quality of concrete would be. In the IS 13311 code book, we know the 4 categories of the concrete: excellent, good, medium, and doubtful. These are the 4 kinds of quality of concrete which use in the code. In this side, we come to know the concrete quality is medium. This shows the quality check during the execution of the building. The compressive strength also very less compared to what they are telling. Actual concrete grade is M25. We should get more than M25 Newton per mm square. But that itself is less, and at least we should get good quality of concrete means that is okay. To do excellent is most of the place excellent is not coming. Good is so what okay. But in that side we come to know that is medium. And we take some steel samples from the building and conducted the tensile strength test in our lab, and we come to know that that 10 mm bar used in the slab is corroded and reduced to the 8.6 mm and 7.5 mm in size, and the actual grade of steel used in the building is Fe415, but you can see that is 280, somewhere around 150 to 200 is coming, which why it will cause. Then we come to know that while doing what kind of water they are using in the execution of the building. While doing the water test only, we come to know the chloride content in the water is very high when compared to the actual permissible standard. For actual permissible standards, 50 ppm, but in that site, what they are using for the execution, the chloride content is 1016 ppm. Due to that chloride, the building collapses and slab failures, the concrete failures. If they are conducting some tests before the construction of the building, that a huge amount of reworking cost will be reduced. That is what I am initially told, that client satisfaction and cost efficiency should be comes once after quality construction. Because by eliminating this test, they would have saved at least minimum 1% of the construction cost. They would have now, without doing the test, they are implementing the building and constructed, and they are utilizing it. After within 10 years, they are going to do the massive rework in the building. That increases the entire cost of the building by simply they are seeing this 1% cost before the construction. That is why I am telling that we should have do some minimum test. I should go to my previous slide. Yeah, quality check. I explain how if we are eliminating the quality check before construction, it may good, then no problem. If something arises, some failures happen, that 1% of the building cost is nothing to the client or to the engineer who's going to build or who would construct that. To do this, uh, I told some test which should be at least we should do this kind of test to ensure the safety by one. For cement, we should go with the finest and initial final setting time and the compression strength of the cement. By doing this compression strength and the fineness, we should come to know the quality of the cement what we are going to use. And still if we go for JSW, Tata Tiscan, that is no problem. Even though the smaller diameters of Tata Tiscan and JSW, we need to verify whether it is safe or not during the bend and rebound. While making the ties and stirrups, we need that smaller diameter steel. So we should verify that. And for bricks, mostly in today's structures, we are planned as a frame structure. Bricks is not a load bearing capacity element in that frame structure, but we should ensure the brick should have proper water absorption and to protect that fire protection capacity. And to core aggregate, we should ensure that core aggregate should be as per the as a IS specification by doing the sieve analysis and water absorption. The same goes for the fine aggregate also. But mainly we should check water. Wherever we go, the water will be differentiate and the each side the water will be differ. For some side we will use bore water, some side we will use the water provided by municipality or corporation or local bodies. Some side we will acquire water from some other source and we will use. So we should do the water testing periodically during the entire construction time. If the construction goes for 2 3 years, we should periodically check the water quality to ensure the proper test. Then we will go for quality check on concrete during the construction phase. Compression test on concrete is a very as or B candidates also do, B students also do in the kind of projects, most of them. So everyone knows the compression test on the concrete procedure. I just indicating the 150 by 150 on the cube size that is told in our active code. And what we should see to the seventh day, we should see certain 60 to 70% of the compressive strength. If the compressive strength is M25, the 70% of the compressive strength should be comes at the day of seventh day, and in 20th day, the compressive strength will be achieved 100%. What we are going to do, M25, M30, M35, M40, everything. During the compression test, during my work in civil testing PPT lab, I come to know the weight of the cube is very much important in the compressive strength. Because in the sites, they do some type of compaction, vibrated compaction or anything, some type of compaction inside the building during the actual execution. But cube, they will cast very good by doing proper 35 groups and 3 layers. While checking the cube, the test will show the proper compressive strength, what they are designed. But actual execution should be differ after because some kind of projects we come to know the cube strength is proper, but during execution only they are doing some kind of vibration. They are missing some parts that will form the failures in the localized spot. So we should ensure that during the compression test, the weight of the tube after during the test should be less than 9 kg, which will give the actual test. Because if the tube weight exceeded the 9 kg or exceeded in the relative terms, we speak, the compression test increases. That is what I come to know during my period fuel testing. So we should ensure what we are doing in the actual execution that should be replicated in our concrete cube. Otherwise, unnecessary expenses like this entity test for the building and extracting the concrete core and do the testing. And next point, we already discussed what are reasons for structural failure. First is material quality. To ensure the material quality, we should go this kind of test for every material. And the construction defects, that is what I am explaining, because the concrete cube differentiates from the actual execution. And the environment factors, we not going to do anything about that is all the hands of the natural elements. And foundation problems, if you are going for some proper soil investigation, then that foundation problem should be rectified. And the poor design. The poor design I mean here is structural design. Why structural design is very much important in the construction field is we all come to know the if the grid clear distance between 10 feet or 16 feet, we will go for the 230 380 mm column, and we'll goes the height, we'll give the 616 numbers of bar. That won't be practiced because the grid is fine, because whatever the load is coming, the seismic load, because in the recent times our Tamil Nadu region is in the zone 2 of our earthquake seismic zone. So we should clarify that thing, and we should go for structural design. That won't affect very much in our cost, and it ensures the safety of the building and stability and efficiency. Even though if we don't require that much amount of steel, at least we should do with at least 1.3 times of the dead load and live load to ensure what is coming here. To know we are doing it right. Without any analysis, we will do. We also have some kind of doubts. To come over the doubt, we should go for structural design and ensure that that structural design is safe, because every plot or every building is differs. Even though the grid center to center distance between the grid is same, is 16 feet or 20 feet, the foundation data will differ from one place to another. Depends upon the foundation data and our FBC value, our column and foundation will be very much different from one building on the. Anyway, the beam is going to the same. For 16 feet, you should pick the deflection criteria and we will design the beam. But to ensure the safety of the building, we should go for construction. Once the soil investigation completed, we should go for the structural design according to our architectural drawing. Then we should integrate our MEP wherever the duct is needed or wherever the pipe is running. It will be easy to secure the building, and also while come across this, while any maintenance is required, while referring the drawing itself, we will do the maintenance. The where should we open the slab? Where should we drill? We want to drill the slab. We want to drill the beam or where the junction box is going. What junction is connected. Those kind of things should be documented. That documents will be given to the client for their maintenance, and it will give the proper flow of the maintenance and the other services requirements in the future. And in the structural design, after doing structural design, I like to highlight some structural detailing here. because some kind of structural detail is missing in our daily execution of the building. Here we see the fixed joint in the column. Wherever the beam and the column is supported, we should use this U-type bar. This U-type bar will be provide our shear factor and provide the shear strength in that joint. It will eliminate that crack which is coming across that joint. Whereas the residential building, if you see, there is moment of building have cracks in that all of these joints. This should be eliminated by providing this U-type bar. And next, termination of column inside the slab. How we are terminating the slab at the terrace? We should use this extra, this kind of bar, shear bar, where we are terminating. Column bar will be go and inserted into the LED disc, and this column bar will go inside the. This is how we terminate that our column inside the roof. Then the beam column junction at exterior. You see that U-type bar and how the column stirrup and bar will be going. The U-type bar should be at least extended up to the LD distance. LD is nothing but a 48 times of the diameter of the bar, what we are going to use here. Then the beam column regular junction, we should provide this crank bar to be ensure that crack won't come. And in the beam during some services is needed, we are giving the opening without any additional reinforcement in the beam. That will affect the beam and have more cracks. To avoid that crack in the future or during the execution, if some kind of opening is coming along the depth of the beam, this we should provide the structural steel, this one, additionally to the beam, and try to avoid the opening closer to the junction. If the opening comes very close to the junction, that will affect our structural stability. And how the openings in the slab should be given. This kind of diagonal bar should be given for additional reinforcement. Apart from this regular slab bar, we can use this additional bar to wherever the openings are coming in the slab to ensure the stability and avoid the cracks near to the opening. That length of this bar is at least 80 times the diameter of the bar. And next, I am trying to show beams at different depths. Once this beam is different depth and this beam is different depth. We have top and bottom rod here. We have top and bottom rod. How should we connect two bars? By providing this Z-shaped bar. By providing the Z-shaped bar, extra bar here, the shear actually here will be taken care of by providing this extra bar. I conclude that this presentation why quality control ensures safe and durable structure. By doing all these procedures, by maintaining proper material strength and geotechnical investigation, proper material testing, and integrating both geotechnical and our structural part is very much important during the execution of the structure and to ensure the quality of the building. And continuous monitoring during the execution is as much as important as the planning of geotechnical investigation, because we have every drawing in our act, but without any execution monitoring, there is no meaning to go through all this process and testing and design. So I request all of you engineers to follow the kind of quality control by maintaining proper material testing and doing the proper geotechnical must in the current world, and go for structural design, whether you know or you are following some practices by hand calculation by some tool, at least go for a foundation design as per the FBC now. And thank you for this opportunity. And if any questions, please ask.
Good evening. Hello.
Good evening, sir.
So I'm engineer Bhupati, so retired superintending engineer.
Yes,
But
sir.
so all is so okay. But reasons for structural failures, I would like to say only one thing,
Yes, sir.
because nobody to take precautionary measures for testing the water, because the water cement ratio at the time of pouring the concrete or whatever may be. Because in case the water is quality is a very is not in the permissible level, it will be created. But you are saying you are shown in your drawings the water, the slabs, the water is draw down in from the field. Is it?
Yes, sir.
In departmental works or private works, what it may be, because after 5 years, this should be happened,
Yes, sir.
because due to water cement ratio is not maintained properly,
Yes.
because the quality of water is very poor.
Yes, sir.
So I want to add one only thing in your in your the reasons are for structural failures. So mainly you mentioned the water quality.
Yes, sir.
Okay. Thank you.
In our case study also, the main thing is the water quality, sir. Because of the chloride content is very much higher than the permissible bit. That is the main cause of the failure in that building.
Yes.
Anything else? Anyone?
Sir, any further questions?
Thank you, Engineer Bhubai sir, senior most engineer in our area, local center in civil engineering. Sir is a retired superintendent engineer. Thank you very much for interacting, sir, Bhubai sir.
Thank you.
And nicely presented, Karthik, and you have narrated what are the essentials. So I request all the members, anybody want to do the construction, so do the proper planning, do the proper design, and testing, and the testing of water as said by the presenter and as well as insisted by Engineer Bhupati sir. So it will not be even 1%. It will be less than 0.2%, 0.3% only, the testing and design cost. So we are, for normal building, we are spending at least 50 to 60 lakhs for the construction. So if you work out that 0.5%, it will be nothing. So I request all the members who have viewed, even the students, so you can take this message, and wherever you do the construction, insist for the testing and quality. So very good presentation, Karthik. Congratulations.
Thank you.
Vote of thanks, sir. The honorary secretary is there. Yes, sir. Satish
Okay.
Kumar,
Well,
sir.
okay, thank you, sir, for quality control and constructions, which is important because we all housed in the constructed. So it is very important. Thank you very much for your presentation. Now, I'd like to request Dr. R. Satish Kumar, Honorary Secretary, IEI Salem Local Center, to thanks. Please, sir.
Thank you, Arumugam sir. Good evening to everyone. It's my pleasure to propose vote of thanks. At the outset, I am very happy to thank our beloved chairman, Engineer S. Loganathan sir, council member, National Council member of IEI. Thank you very much, sir, for arranging wonderful resource person for today's webinar. And I submit my heartfelt thanks to today's resource person, Engineer V. Karthik Priyan sir. Thank you very much for your valuable time and sparing your ideas and a very detailed and insightful presentation. Thank you very much, sir. Thank you all Engineering Talk Committee members, immediate post Chairman Dr. K. Tangaraju sir, immediate post Secretary Madam Dr. C. Daumani Madam, Engineer Armugam sir, Engineer Sendil Kumar sir, Dr. Kumaravel sir, and INR sir, all members, thank you very much for your support in organizing this 123rd webinar. Thank you very much. And thank you all the senior members, committee members, corporate members, student members, all the participants for sparing your time with us. Thank you all. Thank you.
Thank you, Honorary Secretary Dr. Sadish Kumar sir, for your
Sir,
presentation.
sir, thank you,
Okay.
sir. Thank you.